All right, it is the top of the hour, and I want to welcome everybody to our From Research to Implementation webinar series. I'm excited about this month's topic, which is interlayers to reduce reflective cracking. It's something that I battled a lot when I was in the DOT. It was a real big challenge there. I've got a couple of my real dear friends here with us today. I've got Tom Harmon that's here with us with NCAT, and then we've got Vincent Allison, who is with the West Virginia Division of Highways. So Tom Harmon joined the NCAT family about a year ago after 33 years with the Federal Highway Administration, where he had served in a variety of roles. Tom's journey with the FHWA started in the 90s with the implementation of SuperPave. While running the Asphalt Mobile Labs, he also led FHWA's pavement research program at Fairbanks. He trained and technical support for the Resource Center. He led the Everyday Counts program for a while, and he was also the director of NHI. He's got some fantastic hobbies that I enjoy with him. Catch us at a conference together. You'll likely find us in the lobby of the hotel at some point playing guitars together. Also joining us is Vincent Allison with the West Virginia Division of Highways. Vince is a graduate of West Virginia University, where he's also worked with the West Virginia Division of Highways for the last 10 years. He's got experience in all things pavement, from structural design to friction testing. He does pavement analysis. He does pavement preservation work. He's created some really great things there in West Virginia. In his free time, he can be found at a local CrossFit box, which, by the way, he's gotten me into as well. And he also speaks and teaches the international language of Esperanto. So I want to welcome Tom and Vince. At this point, I want to remind everybody, please put your questions in the chat box. I'll go ahead and kick that open. Please keep yourself muted as well so that we can hear our presenters. Given that, I'm going to turn the time over to Tom. Tom.
All right, so good morning, everybody. As Travis said, I'm Tom Harmon, and I'm really fortunate to not only be at NCAT, but today I am at the NCAT test track. So I'm going to talk about not only how we have done interlayers, but I want to start out and talk a little bit about the mechanics associated with how reflective cracking occurs, give you some examples of how we and others have tried to mitigate that, and then get into some specific research that we've accomplished here at the NCAT test track. So first, there's two general mechanisms for how a reflective crack can occur. One is when the underlying pavement system that has a crack through thermal expansion induces a reflective crack back up onto a new layer. The other one is when you have load associated, where as the load travels across, whether it's concrete pavement or a crack that goes all the way through flexible pavement, you'll have the slabs rocking up and down and create a reflective crack that way. And then there is a third, which is a hybrid of those two, where both of them can be happening. So typically, if you don't use a mitigation procedure, a reflective crack will reappear in about 3 to 5 years. There's a general rule of thumb that's anywhere between 1.5 to 2 years per inch of asphalt is how long it'll take. So if you do a 2-inch overlay, in about 3 to 4 years, you'll actually see the reflective crack occur. But the factors that influence that are the underlying pavement condition, the overlay thickness, the loading that you have, your traffic, and the climate. Now, both uncommon and common mitigation approaches, and I encourage you to type in the chat if you've seen these, because there's a few here I haven't seen. The first one is reinforcement. Here's one I haven't seen, using galvanized steel nesting or netting underneath it. You'll notice there's a cost associated, just to give you a relative feel for how much these different treatments cost per square yard. The pricing is based on an International Journal of Pavement Research and Technology paper from 2016. So you got to factor in a little inflation there, but this will give you a relative feel as we dance between the various approaches, how much they cost. So for the galvanized steel, $3 to $5 a square yard. Something that's a little more common that I have seen laid down is fiberglass geogrid. Another version of that is something called GeoNet. And then a glass grid, which is one of the topics I'll be discussing today that happened out the NCAT test track. So this gives you the range of reinforcement techniques that are commonly used or uncommonly in the steel case, used to try and mitigate reflective cracking. If you know of others, please type them in the chat. I'd appreciate that. In addition to reinforcement is stress relief, is to make it so that as the stresses build up in the underlying layer, whether it's through thermal or load, there's some kind of layer there. The first we'll look at is fabric, and fabric was actually part of the experiment I'm going to discuss as well. You can see the pricing there as well. And then a geocomposite. Geocomposite is best if you can think about the pad underneath carpeting. The geocomposite has not only a grid in it, but also a little bit of a sponginess to it to help relieve that stress. You'll notice the price went up on that one considerably compared to some of the other ones we've been looking at. And then a stress-absorbing membrane interlayer, affectionately known as a SAMI. And in a few moments, we'll be hearing from West Virginia and their experience with the SAMI interlayers. If you look at FHWA under their Everyday Counts program, they also promoted TOPS, targeted overlays for pavements. There's a crack attenuating mixture, commonly referred to as a CAM, and then a binder-rich intermediate course or brick. Both of those have been tried to mitigate reflective cracking. One of the other approaches is just to control it. If you have a jointed concrete pavement and you know exactly where the cracks are and they're straight, you can mark, and after you do your asphalt overlay, saw and seal. So you basically seal the crack before it happens and create it in a uniform way. So it's a little bit easier for maintenance. And then probably the preferred is just to get rid of those cracks altogether. If you've got a concrete pavement where the slabs are rocking, you can do a fracture slab method, either break and seat, crack and seat, or the best, which is rubbleize, to eliminate the reflective crack altogether. So it's not going to be creating that maintenance challenge with regard to your pavement. So as I mentioned, you see where that little yellow pin is? That's where I'm sitting today. I'm actually in that building, and we are paving the next round of the test track. So the NCAT test track has gone through 8 research cycles. Each research cycle, we apply over 10 million easels. The 1.7-mile test track is here located in Opelika, Alabama. And we reached a milestone at the end of cycle number 8, where we put in over 11 million miles driven by our tractor fleet. We have 5 trucks that apply the loading on there. And if you can see in the picture, 2 are prevalent within that. 11 million is equivalent to 23 round trips to the moon there and back. And according to Nathan Moore, that's also 17 stops at Buc-ee's by the truckers. So today I encourage you to get your phone out and click on the URLs that are here. The test track website is the best one. And towards the end of the webinar, Travis is going to share with you a screenshot of that. A lot of information readily available. If you want to get directly to some of the information I'm talking about today, that's the middle QR code. And you'll see the chapter in there for Georgia DOT, which is the interlayer study. And then the findings of research, what covers all of our research up to 2024, is that third QR code. So special thanks to Georgia DOT for sponsoring these sections. And actually, as I'm speaking today, Jacob Walker with GDOT is just a few doors down, and I believe he's in a webinar as well, something internal related. So the northern section of the test track, it's called cells N12 and N13, is what I'm going to be discussing, where we've looked on behalf of Georgia DOT at a range of crack relief approaches. In phase 5 of the test track, which occurred in 2012 through 2014, Georgia DOT wanted to look at 2 different approaches to see which one worked better to help retard cracking. So here we see the existing asphalt pavement being solved to emulate cracking. We took a 1/8 inch wide saw, full depth, all the way through the previous perpetual pavement. The intervals longitudinally were at 3 foot and transversely at 15 foot. And what this does is if you assume about 1 foot influence around a working crack, about a third of this pavement section, the 200-foot section, is going to be impacted under load to try and transfer those reflective cracks up through a pavement structure. So in cycle 5 and carried forward in cycle 6, the two interlayers that we looked at were a 0.7 inch double sand and steel coat, and then a 1.1 inch open graded interlayer. The OGI is commonly used in Georgia. Both of them experienced some cracking. The OGI had about half the reflective cracking came up, but the cracks maintained were very small. They were low severity cracks, so under a 1/4 inch. Only 6% of the 0.7 double sand and steel reflect cracked, but when we didn't have the cracking, we had increased rutting. So that's kind of the balance that we're looking at here. So after a 20 million loading or 2 cycles, this is the data we received. At the end of that, Georgia DOT wanted to look at additional methods that they could mitigate or try and retard reflective cracking. So starting in 2018, we went in and milled up those 2 sections, cleaned them out, resanded the joints, and then applied 6 treatments. So each test section was broken into 3. The first looked at interlayers from a fabric to a glass grid, and those were selected by the Geosynthetic Materials Association. They actually put all their members in a hat. This is not folklore. This is what Buzz told me. And pulled out 2 of their member names. Glass Grid and Petromat were selected for the first 2 parts of this. And in a second, I'll show you what that looks like. So here we have, starting in N12, at the top of the screen, you see the Glass Grid. And this is a Glass Grid CG100. They have other products that were placed. The tack coat placed down was a straight asphalt, a PG 6422 was applied at 0.3 gallons per square yard for the Glass Grid and 0.27 gallons per square yard for the Petromat. Of note, Petromat commonly specifies or requests when placing down their product to use a PG 70. In this case, it was decided to keep the tack coat the same. And as you see in a moment with regard to the data, it didn't make a difference. We saw no cracking in either of these sections. Now looking down the lanes, the next one was a virgin chip seal and followed by a wrap chip seal. Both of those had a CRS 2-hour tack that was applied at 0.23 gallons per square yard. And in hindsight, keeping the tack the same for both of these was probably not the best course. We probably should reduce the tack heading into the wrap chip seal because the coated aggregate had less need for the tack to be there. We probably should have reduced that. And you'll see here in a moment that we got a little bit higher rutting compared to these 2 sections. As we step down to the next 2 sections, the next one is an asphalt rubber gap graded or an ARGG, similar to an Arizona process, Arizona gap graded. Under this was a trackless tack. Blackledge Ultrafuge was used with the tack rate of 0.25 gallons per square yard. And then lastly was the OGI, also with the Ultrafuse trackless tack underneath it. Now to performance, you'll see that this was done over cycle 7 and 8, so 20 million easels, 10 million per easel. And at the end, most of the sections had a 1/4 inch or less rutting in them. The wrap chip seal did have the highest. We think that, again, that might be attributed to the higher tack being placed. And the asphalt rubber gap graded came up next with a higher level of rutting compared to the other sections. But this is about cracking. So where do we fall in cracking? Now, before you start looking at the plots, I want you to notice that the traffic loading doesn't start at 0. It starts 1.5 cycles into the experiment. So at 15 million ESOLs is when we saw our first crack. And that first crack then propagated out to around 3.1%. And that was for the asphalt rubber gap graded section. In a moment, I'm going to compare the original experiment to this experiment. Between the original, which happened under cycle 5, and this one, which started under cycle 7, we changed how we were measuring cracks. In the original experiment, we were using the Buzz-O-Matic 2000. That's a joke. Buzz would get down, or a technician would get down and look very closely. And as soon as we could see a crack, it was cracked. These cracks are what we could measure with instrumentation. So more in line with what a DOT would use to determine when a crack initiation occurred. Later, almost towards the end of the experiment, 2 other sections, the RAP and the OGI, also experienced very, very light cracking, less than 1%. Show that graphically. The glass grid, the Petromat, and the virgin chip shield, no cracking after 20 million ESOLs. The RAP and the OGI, 0.8%, and the asphalt rubber gap graded a little over 3%. So during the test track conference, and I encourage you, if you ever get a chance to come to the test track conference, that's where you get to see this. We get to play Dr. Ben Bauer's favorite game, which is Find That Crack. As you look at these 2 sections, this is both the asphalt rubber gap graded on the right and the left, just prior to the end of the cycle, so around 18 million ESOLs. And you can look and look and you'll see, oh, there is a crack right there. That's where we're starting to get that cracking. So even that is relatively, it's low in its thickness, and it's relatively moderate. To take the data and show it to you in more of a balanced approach where we look at rutting versus cracking, here you can see in the purple boxes, we have the double sand and seal tack coat, higher rutting, lower cracking, as opposed to the OGI, which had lower rutting but higher cracking. Again, the cracking was being measured more intently. Again, using the Buzz-O-Matic is my joke. And then if I zoom into this round of experiments, the later round, you'll see that all of the sections performed extremely well in mitigating the cracking. All the cracking was low in severity for the 3 sections that did crack. And we did get a little bit high rutting in 2 of the sections. To look at this more from a rating system, you might say, I came up with my own version of Yelp. This is the Tom Harmon version of Yelp, where the red stars are for rutting and the blue stars are for cracking. If you have 5 stars, you're doing fantastic on cracking. So the top 3, the glass grid, the Petromat, and the virgin chip, no cracking at all. They all had just a little bit of rutting, so I'm only giving 4 out of 5 stars for that. As we step down to the RAP and the OGI, a little bit of cracking, a little bit of rutting, a little bit more rutting in the RAP, and the asphalt rubber gap graded is getting 4 stars for both. For the dollar signs that you would typically see in this type of rating system, this is normalized based on no interlayer, just a full depth cost analysis. Georgia DOT was nice enough to give me some of their 2024 cost data, and then I filled in the blank with publicly facing data on the internet. Just give you a relative feel for which ones are more or less cost effective. So let's take a walk down the track and see what these sections look like towards the end of their loading. This is the glass grid, and we're looking down over all the sections. Very light rutting, no cracking at all. If you were to go out there today, these sections have been milled. A HIMA binder has been used to place an intermediate course, and Georgia has a new section going down looking at things that could be cost competitive with an SMA. They're looking at HIMA binder and modified binders in a balanced mix design. So again, here's the glass grid, little bit of rutting, no cracking. Very, very similar. Here's the Petromat, a little bit of rutting, no cracking. Stepping down, here's the virgin chip seal, a little bit of rutting, no cracking. Now we get just a touch of cracking, 0.8%, and the wrap, 0.4 inches of rutting. Going down a little farther, here we have the highest amount of cracking, but only 3%, and a little bit of rutting in the asphalt rubber, and the OGI rounds it off with 0.8% cracking and a little bit of rutting. So here's what we can say about the interlayer research after 20 million easels, that there is a wide range of interlayer approaches that can be used and have been shown to mitigate reflective cracking or lessen it. We got slightly higher rutting in the wrap chip seal. This is section N13A, most likely due to the impact of the higher tack coat application. We should have backed that off slightly. And then for the asphalt rubber gap graded, we believe the material we placed was a little too flexible, and that's the reason why that one demonstrated the higher cracking. So with that, I really appreciate your attention today. I'm going to hand this off to West Virginia and let them share their story about SAMIs. And I look forward to your questions at the end. So I really appreciate your time and attention. And here's my handoff. Thank you very much.
Again, my name is Vincent Allison. I'm with the West Virginia DOT, and I want to talk about our relatively brief experience with SAMI, the stress-absorbing membrane interlayer. So for those that don't know, SAMI, as Tom had mentioned, is essentially a chip seal with fibers. And that's my basic introduction to it. And it's meant to help with reflective cracking. So some agencies and will put one of these just right on the surface and leave it there. I think Strausser calls theirs a fiber mat. But in West Virginia, our specification treats it as an interlayer. So therefore we require an overlay. So, and I'm using the same picture as Tom here. I can't quite recall where that picture came from originally, but it's a great photo that really shows what's going on there under the hood. So we've got your emulsion spraying down first. That's your first half of that, and there's your fibers that are going down, and then the last half of your emulsion covering them up, so that unless you're actually looking for the fibers, right, those little lines there in the emulsion, you can't really see them. So aside from that application, it just looks like a chip seal afterwards. So you place your chips, your aggregates with a regular old chip spreader, right? And then hit it with your rubber tire rollers, or I guess if you're Kentucky, your steel wheel rollers as well. Ideally without any streaks in it like this. But yeah, a lot of your chip seal best practices are going to apply to your SAMI seal as well. And of course, with any specialized equipment, it's got its own, challenges, right? So here you can see the inside of the machine. I guess we were kind of fortunate on that day to see it break down, but I guess the spools of the fiberglass that were feeding the machine got kind of clogged up. So they were able to open that up, and there's Travis actually. I was doing my pictures of people taking pictures. So we both got that photo there. So in our state specifically, we've done a little over 20 projects, and we've hit ADTs between 300 and 25,000. Our spec generally uses Ashtoe number 8s, and we use a polymer modified emulsion, typically a CRS2P at roughly 0.35 to 0.45 gallons per square yard. Today, I'm going to look at 2 + 4 projects. So 2 projects that are a little older, we'll look at how those are performing, and then 4 projects that are a little newer, and some lessons learned from those, we'll say, and see if we can pick out any trends in there. So here's a project from 2016. It was a rural route, and it had an ADT of about 800. On top of it, we put down 1.25 inches of what we call wearing one, a Marshall mix. The emulsion was a CRS2P at 0.37 gallons per square yard, and this job did not have any milling. And according to our records, tack coat was not used. So here's the road before. Hopefully you can see that there's some cracking and some loss of material even here in the center, with some patching up here, up at the top part of the picture. Drainage is not great, but we're working on that all over the state. And in our next picture, we've got a photo from 2019 from our data collection for our pavement management system. And according to that data, the rutting is in the good category, right? According to Federal Highways condition thresholds. Cracking is good, and the IRI is fair as of 2019. So 3 years later, can't expect IRI to get that much better, especially if you're not putting down, especially if you're not milling, right? But you can see, aside from this edge cracking here, we're looking pretty good. So what's the rule of thumb, right? We've got 1 inch of cracking per year through 1 inch of asphalt. So after 3 years, you would probably expect to see some cracking, but at least from this photo, we're not seeing much of that. Okay, here's one of my favorite ones. This one was in 2018, and this was on a multi-lane job. This is actually an exit off of the interstate. So these turns here go off to Interstate 64. So a lot of traffic coming in and out, especially truck traffic. Our ADT was 10,000. And on this job, we put 1.5 inches of 12.5 super pave. Again, our emulsion was a CRS2P at 0.37 gallons per square yard. And as you can see, this one was concrete. It was originally concrete. And I'm seeing that a tack coat was not used for this project. So as you can see, we're in pretty rough shape with our concrete patching here at the joints, especially as we approach the intersection here. And as you can see, we've got that patching all up along this concrete stretch of road. Here's a photo from 2022. And again, our rutting is in the good category, cracking is in the good category, and our IRI is fair at 127. So there's 4 years of traffic, and you can see those cracks coming back over where those patches were. Obviously, we're seeing a lot of wear on this road. The good thing about this is we've got our top-down views of the road, right? So on the left we've got 2020, and on the right we've got 2022. This is from our data collection. Michael Baker at the time. Fugro does our collection now, but you can see on the left picture here, very slight. I think we need the Buzz doing that collection to see that crack here on the upper part of the 2020 picture. I think most normal human beings could probably see this lower one here in 2020, and then in 2022 we've definitely got some cracks here. So this brings up the question of, we put 1.5 inches, and after 2 years we're starting to see cracking again. So the question is that SAMI seal helping with the reflective cracking or not? Right? Would we have had similar results if we just put 1.5 inches without that SAMI seal? Think about it for a second. If you're an agency, are you happy with these results? To me, my answer is, given the condition of these cracks as they are now, if the road originally looked like that, then no, I wouldn't be happy. But I would say keep in mind the original condition of this road. It was obviously in very rough shape to have these massive patches. Plenty of traffic, plenty of truck traffic. I think we're doing pretty all right here. And of course, you can't know unless you've got a control section, which for this project we did not. But who knows what it could have looked like without the SAMI seal. It might have looked like this right picture in 2020, right, instead of 2022. So I guess this is as good a point as any to remind everyone that you're never really going to completely get rid of reflective cracking unless, like Tom said, you really deal with the base with rubberization or removal and replacement. I was told a long time ago, if anybody claims they can eliminate reflective cracking, they're probably lying. So yeah, we've slowed it down here, I think. So we'll look at some newer SAMI jobs and some of the things that we've learned from those. Here's a project in 2021. This was going through town. ADT of about 2,900. And the overlay on top of this was 2 inches of 12.5 super pave. Again, there's our CRS2P emulsion at 0.39. And we did do fine milling on this stretch of road as well. I think the primary purpose of that really was to maintain grade with the curb and gutter there. And this project did use a tack coat. It was an SS1H. So here's a picture of the SAMI. Pretty decent application, fairly uniform. And here's a picture after. So we got good density results, 92.7 to 94 on the paving mat. And the IRI after completion was 164, and that was down from 294. So pretty good improvement there. Of course, you can't expect the smoothest thing, right? Going through town over all kinds of utilities and things like that. But yeah, we were happy with this project. To my knowledge, we didn't hear any bad news. And as we say in the central office here in West Virginia, no news is good news, right? So this one seemed to went off without a hitch. The district liked it. The district was happy with the results. Unfortunately, I've not done any follow-up since 2021. Okay, this is where things start to get interesting. This project was a multi-lane job on what we call Corridor G, US 119. This was in 2020. It's a multi-lane job, 19,000 ADT. So we're really getting up there now. We put 2 inches of 12.5 super pave on top of the SAMI. And the emulsion again was a CRS2P. This job also included milling prior to the SAMI, and there was a tack coat that was used. And we heard relatively early on that the district was having issues getting density results. There was shoving of the asphalt on top of that SAMI layer. And of course, one of the first questions you ask is, did the SAMI have time to cure out? So we were told that there was 2 days between placement of the SAMI and the overlay. By the way, you can see, of course, 2020, the sign there, stay at home order, westvirginia.gov. So this was COVID for sure, COVID times. So here were the pictures that the district had sent us. You can see our SAMI layer here is definitely shoving from whatever I assume from the rollers, from trying to get density. And you can see that the material that they were able to pick up from that was, not very stable. You can see the fibers keeping things together. Yeah, so that is not what you want to see when you're trying to compact asphalt. You don't want the ground moving underneath you. So here's that same job in 2022. Picture from our pavement data collection. What they ended up doing was they pulled that SAMI seal on some parts of the project as they were paving. However, we did pay bonuses for smoothness, so it had good results there, and density results were between 89 and 96, and I'm talking about on the main line there, not the shoulder. So how much did the shoving from the SAMI really affect the density of the overlay? So I pulled up all the data from the density results of each individual lot, and again, this is all from the main line. These blue data points are our average densities per lot with the SAMI seal. And then the red dots, the two red dots here, are without the SAMI seal. So I guess just looking at the numbers here, you could say, oh, the average density increased by a whole percentage point. You could argue that that's pretty significant. But if you look at the actual data points here, this first red dot is kind of right in line with all of the other data points with the SAMI. And this one without the SAMI is way above. So again, it's only 2 lots, but I'd say that was a little inconclusive. Perhaps it helped to forego the SAMI on a couple of those sections. Okay, so fast forward to 2021, another multi-lane project, 9,000 plus ADT. And this one, the district really wanted to delay their reflective cracking. So they put a total of 4 inches on top of the SAMI, on top of this concrete road here. And in addition to that, this project included a joint membrane material. So you can see these at pretty much every joint here, these little humps. And I think the district was going for kind of like a belt and suspenders kind of thing, right? So they put this asphalt membrane over the joints, which we won't talk about that too much today. And on top of that, they did our SAMI seal here that we've been talking about. Unfortunately, that kind of came back to bite them, because as you can see in the picture here, the asphalt was kind of shoving and humping up and stopping at those membranes on the joints, and obviously causing some issues with density. So we had some folks go out to the job site, talk to the contractors, and talk to the SAMI salesman. And the idea at the time was that things were too hot, right? So it was a hot summer day. We're putting 2.5 inches of a 19 millimeter mix on top of the SAMI. And the thought at the time was that thick of asphalt was essentially reheating the emulsion in the SAMI, causing things to be, again, unstable and kind of moving. Now, this project did not include a tack coat, unfortunately, because after that project in 2020 that we just looked at, the theory there was that there was just too much emulsion between the tack coat and the SAMI seal. So the opinion at the time was that there's too much emulsion here. It's reliquefying and causing things to move and preventing us from getting density. So the conclusion there was to add in a layer of what we call scratch, right? Just a 1/2 inch of asphalt to kind of act as a barrier between that 2.5 inches of hot asphalt, right? A thermal barrier is really what it was, between that and the SAMI seal. So that ended up working, actually, and it solved the problem at a cost, of course, but things turned out well. We had an average IRI of 48, of course, with 4 inches of asphalt. We're able to get some lower numbers there. Average densities on that 19 millimeter prior to applying the scratch were 91.8, and after the scratch was 93.3 to 96. So obviously that layer of scratch helped. So that brings us to 2022. We're doing SAMI seal on the interstate now, where our ADT is over 24,000. This is near Beckley on Interstate 64. Again, we're going for a 4-inch total, right? 2.5 of 19 millimeter, 1.5 of 9.5. And again, because of that project in 2020, where there was a lot of movement, they decided to forego the tack coat again. And this time they gave it, I think they said a whole week after placement of the SAMI layer before trying to put the overlay. So again, they were still having issues with compaction due to the asphalt shoving. And, we decided that as we were out there looking at this project, of course, after the problems the 2 years prior, we were out there on day one trying to make sure that we could get ahead of things as much as we could. So you can see the paver's way down there, and the first roller has made his passes, and he's right behind the paver. What we did was we put some spray paint on the asphalt to see just how much it was moving as the rollers were going over it. And this is one pass after the second roller. So just one pass, we moved 1 to 2 inches here. Obviously not what you want to see if you're trying to compact your asphalt. If it's moving around, you can't get that dense. So ultimately what they decided to do was to stop paving here and include that 1/2 inch of scratch again. So big change order went through, $772,000 to put that 1/2 inch of scratch at $124 a ton. And after that, densities were between 92 and 94. But as you can see in this picture here, things end up turning out okay. So we had, 4 lanes at least in this section where we've got an on-ramp. 3 lanes was the majority of the main line. So that brings us to our summary. So we've had multiple contractors and kind of mixed results, right? We've had slipping or shoving, I guess, on both milled asphalt and concrete. Cooling did not seem to help, right? Letting the asphalt sit for a minute, and that was back on this project. So as you can see, they're way down there, and the idea was to wait a little bit to make sure that the asphalt wasn't too hot, right? Maybe one of the theories was that it was too hot, and that's why it was moving so much. However, it does seem that in all cases, that 1/2 inch layer of scratch seems to help. So at this point, we've told our designers to include that 1/2 inch layer of scratch from the start on future jobs. But at that point, it brings up the question of, what's the cost of that? You're doing multiple passes already for the SAMI. You're adding a 1/2 inch of scratch, and at what point would it be better to just pave thicker, right? Because that also is a method of delaying that cracking from showing up at the top. It is my opinion that we've kind of let the pendulum swing too far from one side to the other. So, sure, on those early jobs, we had some shoving with a lot of emulsion. But it's my opinion that on that later job, the 2022 project, that since we had a whole week for that emulsion to set up and be experienced to some traffic, I think if we would have put a tack coat on top of that, I think we would have been okay. But we've yet to find a district that is willing to take that risk and try that out. You know, if we do everything as we should to make it, you know, best practices and all that for both the SAMI seal layer, your chip seal best practices, and the tack coat on top of that. And that's all I've got. I guess it's worth mentioning that these pictures here are not AI generated. I guess I've got to clarify that these days. These are real pictures from one of our warranty projects. The contractor decided to have a little bit of fun with their crack seal. So we've got smiley face and a flying WV out there on the interstate that you can still see today. All right, lots of questions.
In fact, you can even see those with Google Maps if you know right where to look.
Yeah.
So it's pretty fun. All right, well, cool. Let me I'm gonna take over the screen here. All righty, so some of the real takeaways from the things that we've talked about today that I kind of wanted to cover is that I think we heard from both Tom and from Vince that we're not going to stop the reflective cracking all the way. We're not going to eliminate it from happening. But what we can do is we can slow it down, and that really is the goal. Is what methods do we have? What things can we use that are going to slow that cracking down? And there's many options to choose from. Tom went through a whole list of different options that we've tried on the test track and some that we've not even tried on the test track. And then Vince also showed where that they had done a belt and suspenders and used a couple there together. I know one of the things to consider there when using those different options is what happens during the next cycle of reconstruction. You know, there was some discussion about the galvanized grid. You know, how does that come up? How does that mill? I know I've seen several projects where there was a geosynthetic fabric that was in the pavement that the designers didn't necessarily know about, and as the construction process got into that geosynthetic, they had some issues. I know Vince and I saw one in West Virginia together, and I've seen one on a runway that it really turned into a mess because we need to think and be cognizant about what happens next with this. Most of the options that have been used on the test track have shown some success, right? Have seen a slowed cracking there, seem to have done the job that we asked it to do. West Virginia has definitely seen some success with the fiber reinforced interlayers, but they've also had some challenges. I think Vince showed us several projects where they were really happy with how it did slow down that cracking. But I think that condition of the road it's going to be overlaid on makes a big deal. If we look at the one that he had that had all the concrete patching, you know, those reflective cracks did come back through. Obviously, that road was in pretty rough shape before they did the interlayer there. So similar to preservation, you know, project selection is important here. We need to make sure that we're picking the right kind of an interlayer for the distresses that we have. The next one is kind of a takeaway from West Virginia's experience there is care needs to be taken with the application rates, the temperatures. Sounds like they've had several experiences where they've had to kind of change things up a little bit, or they've learned their lessons. You know, it's one of the reasons I wanted to have Vince here is to talk about some of those lessons they learned so that he could pass those on to the rest of you. So nonetheless, those are some of the couple things that I saw as takeaways. Now we do have a few questions in here that I would like to go ahead and hit. I think Tom has answered some of them, but I want to read a few of them out there as well, so that everybody can get that information. So Tom, for you in here for the GDOT sponsored track, what pavement type was saw cut into the slabs?
Down at NCAT, our test track is made out of asphalt. So I'm going to say asphalt.
That's right. That's right. Oh, and so I know years ago there was some discussion about trying to put some concrete slabs under some asphalt, and our board of directors decided that that was not the best option for us, and so we have not done that. So we're trying to emulate that system by creating these saw cuts all the way through the depths of the underlying asphalt. So Tom, what was the spacing on those joints?
So we did 3-foot intervals longitudinally and 15 transversely. There's a new study that's going to be with Oklahoma DOT that's going to look at block cracking. That's 4x4 full depth cuts and then 4x8. So we'll be looking at how block cracking is mitigated by a balanced mix design mix here in the next cycle.
Okay. Okay. And so did you notice in the data as you looked through the cracking, and I realize you weren't here when it was originally constructed, but you've been handed this adventure. Did you find that the cracks that did come to the surface on the test track did correlate with the saw cuts, or were they offset, or what did you find?
Yeah, so the cracking mostly followed where the saw cutting was, but obviously the one photograph I showed where it was fine, the crack, it looked more like a tree branching out. So that was in the general vicinity. When we talk about the influence of a crack, it's usually around a foot to each side. And with that level of saw cutting, yes, I answered that mostly, but not all.
Yeah, yeah. Okay, and then there was a tack coat was applied when the petromat was used there. And
Yes.
so could you speak to what that tack was?
So for our tax, we had a straight PG 6422 that was under both the glass grid and the petromat, and the dosage rate was 0.27 gallons per square yard for the petromat. And then for the virgin and wrap chips, we did a CRS 2-hour set that was at 0.23. And then the last two, we did the Blackledge Ultrafuge trackless tack at 0.25. And I really encourage people to go out to the track website. That's in the summary of the report as well. You'll get a sense of what's out there. I also mentioned that Petromat uses a PG 70 grade. So whether it's a 22 or otherwise, they usually want a slightly stiffer binder underneath their product. But we didn't see any cracking. So I think the 64 shows it works fine. And then just a side note that's not in the questions, you mentioned some of the challenges removing these. When Nathan Moore had the milling crew out taking up these two sections, both the glass grid and the petromat milled up just fine. We had no issues with the milling head, but we were very cognizant that where that layer was, but they milled up just fine.
Yeah. Okay. Well, great. And there were not control sections that were done with that particular.
There were not control sections. If we put that 9.5 millimeter mix that Georgia has on a good section, it would still be out there carrying traffic today. And the fact we got no cracking and very little rutting in the first three sections, that's probably an indication what a control would have done.
Yeah, I agree with you. I agree. And then that is a challenge. I think there was a comment that was brought up here about do we feel like we're seeing the same kind of rocking in asphalt cut that way that we would in concrete? And Tom, I totally agree with you that a rigid pavement is going to probably rock more than what we would see with a flexible pavement.
Yeah, and for the designers out there, you can take an FWD out and look at load transfer for your concrete slabs to figure out what kind of movement. If you truly have high strains or high rocking of your slabs, you should be looking at one of those slab fracturing modes, whether it's break and seat, crack and seat, or rubbleize. There was a study done years ago, Napa, that shows rubbleize is obviously going to be the best at getting it back, but then you have to worry about do you have clearances and other things to do the asphalt overlay. But yeah, you should always check your slab sufficiency. If the slab's just moving tremendously, it doesn't matter what you put over it, you're going to have some issues. But
yeah, and there are options to stabilize under those if you need to as well. So that makes sense. All right, Vince, question came in for you here. Were there dowel bars that were in that existing concrete in the projects that you guys overlaid with the SAMI?
So I can't say with 100% certainty, but I can say with 90% certainty that most of, if not all of our concrete that we're constructing has got dowel bars. Of course, those projects were older. So I can't say for certain, but if I had to bet, I would bet a reasonable amount of money that they had dowel bars.
Cool. All right, great. And then with your application rates that you were showing there on the SAMI seal, is that the spray rate from both of the bars, or is that just from one of the bars?
I believe so. Yeah, I don't think we would specify each individual spray bar.
I agree with you. Those application rates were fairly high, so I do think that those were
Yeah.
probably both of those. And so on the tack coat, did you assume the binders would provide bond with the overlay?
Yeah, I replied in thread there, but yeah, basically that was the idea at the time, since that is as we mentioned, it's a pretty high application rate there for the SAMI, and the idea was that would kind of work its way up after being exposed to the heat of the overlay. So yeah.
Okay. And then I'm going to throw you a real big curveball here, Vince. I know that there has been some of that, the reflective cracking membranes that have been put on several projects. Have you guys seen success with that, or is that not done as well as the SAMIs? What's your take on that?
We've done a very small handful of those, and unfortunately, I don't think we've got enough time with those yet to get to know for sure how effective they are.
Yeah.
But I guess to report, I could report that there's been no bad news. So back to my statement of no bad news is good news.
There you go. That sounds like a Stanovich quote to me.
Yeah.
So, hey, well, excellent, excellent. So I'm seeing that's kind of the end of the questions that have been in here, which I think is great. A couple things that I always want to make sure and cover. Tom did talk about this here a few minutes ago, that if you do visit our website at ncat.us, that you can get in there and find the research, and you can find these test track findings documents. You can find the test track full reports, and you can find additional information on what we've done on the track when it comes to these. It's got a pretty good search function in our research website there, where you can search specific topics and find what you need to there. I also want to make sure that we plug a little bit that another place to go and find specific information that includes the NCAT research is to, did they rename him, Tom? I think they renamed him Mac Ruber. No, what they rename him? They named him Mac Adam, right? That Hey Nap has been renamed. You're muted. You're muted still.
You're making me laugh. Did they really do that?
I think they did. The Hey Napa website is a fantastic place to go and find these kind of resources, and it only draws from NCAT research, FHWA published documents, and from NAPIS published documents. So it's vetted information. It's not pulling from the whole of the internet. It is built on the Chat GPT software, so it is a fantastic resource. But it also gives you all of the references to anything that you looked at. You can look at the PDFs. You can look at the full, or you can look at just the page that it came from. Great resource, in my opinion, as well. You can find more information. Did want to kind of throw and make sure that you've got a chance to see the emails of the different folks that were here today if you have additional questions. Okay, so it is Mac Adam now. I just see somebody kicked in there. I think that changed last week, Tom. I think that's when that changed while we were at comp enjoying ourselves there, spending some times with our friends from the different DOTs. But it did change to Mac Adam. So, but here's your emails. If you want to take a screenshot of those or whatever, when it comes to us at NCAT, you can always come to our website and find our contact information there. Got to plug my Training in Your Pocket program. If you get a chance to look there, we're getting some good subscribers. If you're not subscribed, please do check those videos out. We've got new ones that are coming out again. We've got a new one I think comes out next week on the sand patch test to check the milling depth or macro texture of a pavement, which is a fun one as well. And we're continuing to film those and push those out. If there's any of those that you think that we need to do, don't hesitate to reach out to me and let me know if there's something you think we should be doing with that Training in Your Pocket program. Feel free to reach out to us for different training opportunities if there's something we can do to serve you when it comes to general general courses, balanced mixed design courses, mixed design courses, specialty mixed design courses we've even done. We can customize all sorts of things there and bring training to you, or you can come to us. But that is my main role here, and I would love to come and spend more time with you. So to kind of preface our next month, September 19th at 10 a.m., we're always that third Thursday. Next month, we're going to talk about practical considerations for BMD benchmarking. We're going to have this one is going to be really fun to me because we're going to have some discussion about what things need to be done in the laboratory as you're benchmarking and what things need to be done from an agency perspective, from that higher level perspective. So I do think that this is going to be a good one. Anytime you see this QR code and it's related to the logo you see in the upper right-hand corner or from a research to implementation webinar series, that's going to take you to the latest version. So anytime you see that QR code, it's going to take you to the latest version. That registration is open for September already, and we can go from there. Vince, do you have anything closing out?
Nope, nothing for me.
All right. Well, I appreciate you being here with us. It's always great to see you. We'll have to share workouts later today and figure out who can sweat more. That work? Okay, sounds good. Tom, have you got anything before you go? Don't forget to unmute.
Nope. I got my hard hat here. I'm looking forward to go out and seeing the construction today with Jacob Walker. And yeah, just please let us know if you have any other questions or reach out with anything. I really enjoyed this today, and Vincent, good seeing you, and everybody have a great day.
Sounds good. Thank you everybody very much. We'll see you next month.